we are discussing about one of the important topics from the organic chemistry, fundamentals of organic reaction mechanism. And in the second part of this topic, we have just started what is meant by reaction intermediates. Actually, in chemical reaction, there is a conversion of reactant into product, and each and every chemical reaction maybe takes place in number of steps. It may be involve formation of some intermediates, and that important intermediates are called reaction intermediates. And in organic reaction, generally there is a formation of some intermediates like carbocation, carbanion, free radicals, carbenes, nitrines, and arines. These are some of the examples of reaction intermediates which are formed in the organic reaction. And we also completed first study of first reactive intermediate carbocation in detail. Okay, here we have studied what is meant by carbocation, means definition of that carbocation. Actually, this is positively charged carbon species, trivalent positively charged carbon species, which having 6 electrons in its valence shell. Okay, this is the carbocation. Okay, then it is electron deficient species. It acts as a Lewis acid, etc. Then second step is the formation, means how that reactive intermediate, how that carbocation is formed during the chemical reaction. Next step is the structure, means we have studied some of the important properties related to the structure of carbocation, just the hybridization of that particular carbon, then what is the geometry and bond angle of that species, etc. Then next is the stability. We have studied comparative stability of different examples of carbocation, and what is the effect of, what is the influence of inductive effect on the stability of carbocation. We have studied how the tertiary carbocation is more stable than secondary and how it is more stable than primary. Okay, this is just about the stability. And last part we have studied reactivity, just example of simple organic reaction, and that reaction involve formation of carbocation as an intermediate. Okay, this is about the first reactive intermediate carbocation we have already studied in last lecture. Okay, now let us see next one. यामधला next पुढचा intermediate आपण study करतोय in the same manner in that 5 step. And next, again very important reaction intermediate is the carbanion. Now let us see first about the introduction of carbocation. Now before going towards its definition, I will explain how that carbanion, how that reaction intermediate is generated in chemical reaction. Okay, let us see a very simple example, general example actually. This is organic compound. Carbon having 4 covalent bond, it having one bond with the X. Suppose this bond between carbon and X, this is covalent bond. Suppose in presence of polar solvent, that bond undergo heterolytic breaking. Heterolytic breaking, and suppose that carbon is more electronegative than X, then during bond breaking, this electron pair, that shared pair of electron, it goes towards carbon, and that carbon acquires negative charge. Okay, during this bond breaking, electron pair goes towards carbon because it is more electronegative than X, and therefore that bonded electron goes towards carbon, it acquires negative charge, and X acquire positive charge, and thus there is a formation of negatively charged carbon species. And if carbon having negative charge, then that species is called carbanion. That species is the carbanion. Now what is the main concept regarding that carbanion? What is the main concept? We can say in first step, yes, it is trivalent, it having 3 covalent bond. In carbanion, carbon having 3 covalent bond means it is trivalent. Then that carbon having negative charge means it is negatively charged species. This is again important concept. And now, how many electrons are there in the valence shell of carbon? How many electrons are there? We know that there are 3 covalent bonds. Each bond contributes 1 electron pair, means there are 6 bonded electrons. This bond having 2 electrons, this bond having 2 electrons, this bond having 2 electrons, the 6 bonded electron, and there is a negative charge. We know that negative charge means there is electron pair. Thus there are total 6 bonded and 2 electrons from the negative charge. means there are totally 8 electrons in its valence shell. Simply we can say that in carbanion there are 8 electrons in its valence shell. Okay, these are the three main concepts. These are the three main properties of the carbanion. One, it is a trivalent, it having 3 covalent bonds. Second, it is a negatively charged carbon species. And third one is the, yes, it having 8 electrons in its valence shell. Now, how will you define that species? How will you define the carbanion? Yes, trivalent, negatively charged carbon species which having 8 electrons in its valence shell is called carbanion. This is simple definition for the carbanion. The trivalent, negatively charged carbon species which having 8 electrons in its valence shell is called carbanion. Now let us see some properties regarding the carbanion. In the introduction, we have to study some properties also. Let us see some properties. Yes, it is denoted as a R minus or C minus. Carbocation was denoted by C plus or R plus. Here it is denoted by R minus or C minus. Okay, simple point. Then second, yes, it is electron rich species. There is a negative charge, means it is electron rich species, and we know that negatively charged ions are called nucleophile. And here also carbanion having negative charge, carbon having negative charge, therefore it is nucleophile. Okay, now in a chemical reaction, that species having negative charge, therefore in chemical reaction it can donate this electron pair to another substance and form a bond with that substance. And therefore simply we can say that according to the Lewis theory, that compound having ability to donate electron pair to स्वतःकडे असणारी electron pair it can donate to another substance, and therefore it acts as a Lewis base. And therefore fourth point is the, yes, it acts as a Lewis base. Okay, this is just about the introduction of carbanion. We have studied in the introduction definition and some properties of carbanion. Okay, and this is the example of this carbanion CH. Suppose that CH2 CH2 CHO carbon having negative charge, then there is a CH3 carbon having negative charge. These are the examples of carbanion. Okay, now how will you define it? Simply, yes, trivalent negatively charged carbon species having 8 electrons in its valence shell is called carbanion. It is denoted as a R minus or C minus. It is an electron rich species, and it is a nucleophile, and it acts as a Lewis base because it having tendency to donate electron pair to another substance, and hence according to the Lewis theory, yes, it should be act as a base. Okay, this is just about the introduction of carbanion first step. Now let us see second step, formation. In formation, we are going to discuss how that species are formed, how they are generated in the chemical reaction. Generally, carbanions are formed due to heterolytic bond fission. They are formed due to heterolytic bond breaking. Let us see same example I have explained in the introduction. Yes, this is organic compound. Suppose there is a bond between carbon and X, and if during the bond breaking, generally that bond undergo heterolytic fission in presence of polar solvent. In presence of polar solvent, there is a heterolytic bond breaking. And suppose here carbon is more electronegative than X, then what happens? That bonded electron pair goes towards carbon, it acquire negative charge, while X acquire positive charge, and that negatively charged carbon species is nothing but the carbanion. Okay, this is the first method how the carbanions are generated due to simple heterolytic bond breaking in presence of polar solvent. We get the carbanion. Let us say another example. Suppose this is example of ketone. This is a ketone CH3, C double bond O, CH3 actually. There is CH3, but for just convenience, तुम्हाला लक्षात यावं म्हणून just for your understanding, I have showed that hydrogen separately. Okay, this is acetone, example of ketone. The molecule is acetone, CH3, C double bond O, CH3. Suppose in presence of base, what happens? Here that molecule loses alpha hydrogen atom, means that base takes that hydrogen, OH minus ion takes that hydrogen atom, that OH minus and hydrogen, it forms H2O. I have written minus H2O on the arrow. Okay, Now, during that process, bond between carbon and hydrogen, this bond between carbon and hydrogen, it undergo heterolytic breaking, and that electron pair goes on the carbon. Okay, and thus when that electron pair goes on the carbon, it acquires negative charge, and that species is called carbanion. That species is called carbanion, and thus when ketone is created with the base, there is a heterolytic bond breaking in between carbon and hydrogen, and therefore there is a formation of negatively charged carbon species, and this is called as the carbanion. Okay, and this is just a second step, how the carbanions are generated, how the carbanions are formed during the chemical reaction. This is the second step, just due to heterolytic bond breaking. Now let us see third step. Third step, structure. Okay, this is again a very simple concept. Now, in carbanion, we know that carbon is having three covalent bond. There is a negative charge. Negative charge on the carbon means there is electron pair, non-bonded electron pair. Negative charge means there is electron pair. Okay. Now, the carbon here, this carbon is having sp2, sorry, sp3 hybridization. Hybridization of that carbon. आपण मागे पाहिलं होतं, in case of the carbanion, hybridization of carbon was sp2, but in that case hybridization of carbon is a sp3, means there are four hybrid orbital. There are four hybrid orbital. Out of that four hybrid orbital, three orbital form three covalent bond. Suppose this is the central carbon, and three sp3 hybrid orbitals of carbon form three covalent bond. These are the three covalent bond. Okay, now there is a formation of three sigma bond, three sigma covalent bond. Now there is a one sp3 hybrid orbital, and suppose this is the one sp3 hybrid orbital, and this is the sp3 hybrid orbital. It having lone pair of electron. Which lone pair of electron? There is a negative charge, means electron pair, and this is the electron pair, and that electron pair is present in the sp3 hybrid orbital. This electron pair is present in the sp3 hybrid orbital. And okay, this is the third point. And last one, what should be the geometry of the molecule? Generally, if the hybridization is sp3, then we are saying that geometry should be tetrahedral, right? Tetrahedral. But in this case, one hybrid orbital do not participate in the bond formation. That hybrid orbital, हे जे hybrid orbital आहे, ते bond formation मध्ये involve होत नाही. It having lone pair of electron. Therefore, for geometry, we are considering only those orbital which participate in the bond formation. म्हणजे वरचं ऑर्बिटल आपण कन्सिडर करत नाहीये regarding the geometry. And here that molecule, that species looks like a pyramid. It looks like a pyramid. Okay, just like ammonia molecule, here also that carbanion looks like a pyramid. Hence, geometry is a pyramidal, and this bond angle is here. This bond angle is 107 degree. Okay, this is the bond angle 107 degree. This is about the structure of carbanion. Okay, we have studied only 4 points regarding the carbanion. What is the first point? Yes, hybridization of carbanion is sp3. Then second, that three sp3 hybrid orbital form three sigma covalent bond. Then third one, yes, one of the sp3 hybrid orbital having lone pair of electron. There is a negative charge, but there is electron pair, and that electron pair is present in that hybrid orbital. And last point, geometry is a pyramidal with bond angle 107 degree. This is just about the structure of carbanion. Now let us see next point, stability. Now here we are going to discuss comparative stability among some examples of carbanion. Okay, and actually how the inductive effect, actually in the stability of carbanion, there is a role of inductive effect, there is a role of resonance effect, and also there is a role of hyperconjugation effect. But here we have to study only how the inductive effect influence on the stability of carbanion. Okay, now let us see some examples of carbanion and how there is a role of inductive effect. Okay, consider a very simple example of carbanion. Here carbon is attached to three hydrogen. This is the methyl carbanion. carbon having negative charge. Okay, this is the methyl carbanion. Consider another example. Suppose one of the hydrogen atom is replaced by fluorine. Hydrogen is replaced by fluorine. Now let us see comparison between that two example. Comparison between that two carbanion. Both are carbanion because in both cases, in both the example, carbon is having negative charge. Let us see which is more stable and why it is more stable. Now, here in this example, there is a fluorine atom. We know that fluorine is a more electronegative than carbon. Fluorine is more electronegative than carbon. Therefore, what happens here? The bonded electron pair in between that fluorine and carbon, there is a covalent bond. Means there is an electron pair, and this electron pair is just pulled towards fluorine. It attracts this electron pair towards itself, and this is called as the electron withdrawing inductive effect. This is called minus I effect. Means there is a minus I effect. Okay, I will repeat again, I will revise again. Actually, in carbanion, central carbon having negative charge means it is electron rich center. There is electron rich center, and here that fluorine atom pulled bonded electron pair towards itself means it shows minus I effect, electron withdrawing inductive effect. Now here what happens? Carbon, central carbon is electron rich, and when electron withdrawing group is attached to that central carbon, then it becomes more stable. What is the statement? What is the main statement? Just concentrate on that statement. Carbon, central carbon is electron rich, and therefore when electron withdrawing group is attached to that central carbon, it becomes more stable. It becomes more stable. म्हणजे सेंट्रल कार्बन कडे इलेक्ट्रॉन जास्त आहेत, इट इज इलेक्ट्रॉन रिच, आणि त्याला जर आपण इलेक्ट्रॉन विड्रॉइंग ग्रुप जोडला, then it becomes more stable. Therefore that carbanion is more stable than methyl one. While in the next case, पुढच्या केस मध्ये आपण बघूया, here there are two fluorine atom. Means again there is a more electron withdrawing effect because both the fluorine atom shows minus I effect. There is electron withdrawing inductive effect. Therefore this carbanion is again more stable than second one. Okay, now let us see one more example. Here there are three fluorine atom, means there is again more minus I effect, electron withdrawing inductive effect. Therefore this carbanion is more stable than third one. Okay, this is just about the stability of carbanion, different carbanion, and what is the role of that fluorine, what is the role of electron withdrawing inductive effect in the stability of that carbanion. Let us see one more example. Consider, suppose I will take another example. This is the primary carbanion. Okay, here one hydrogen from the methyl is replaced by methyl group. Okay, this is the primary carbanion. Now what is the role of methyl group? Yes, it is example of alkyl group. Alkyl group always shows electron donating inductive effect. Okay, we know that very well. Now here central carbon is electron rich, and if any electron donating group is attached to that central carbon, then that carbanion becomes less stable. What is the statement? Listen carefully. Here methyl group shows electron donating inductive effect, means there is a plus I effect. And here central carbon is electron rich, and if any electron donating group is attached to that central carbon, then it becomes less stable. Therefore it is less stable. Methyl primary carbanion is less stable because there is a plus I effect. म्हणजे सेंट्रल कार्बन हा इलेक्ट्रॉन रिच आहे, आणि त्याला जर आपण इलेक्ट्रॉन देणारा ग्रुप जोडला, इलेक्ट्रॉन डोनेटिंग ग्रुप अटॅच केला, then it becomes less stable. Okay, this is the next example. Let us see one more example. Here there are again two methyl group, means there is a more plus I effect. Therefore this secondary carbanion is again less stable. While suppose the tertiary carbanion, it having three methyl group, means again there is a more plus I effect. There is a plus I effect, electron donating inductive effect. Therefore its stability decreases. and hence tertiary carbanion is less stable. This is just about the stability of carbanion. Now there are two important statements regarding that stability. First, electron withdrawing group increases the stability of carbanion. Which electron group? There may be fluorine, chlorine, bromine, NO2, etc. Any more electronegative atom or group, they show minus I factor and they increases the stability of carbanion. While electron donating group, for example, any alkyl group, they are electron donating, methyl, ethyl, and propyl, etc. They decreases the stability of carbanion. Okay, this is just about the stability of carbanion and how there is a role of, how there is influence of inductive effect on the stability of carbanion. Now let us see last point, last step of the particular concept, reactivity of carbanion. Now here we are going to discuss simple example of organic reaction and how there is a formation of carbanion as an intermediate during that particular reaction. Okay, let us see a very simple example. Now what is the name of compound? Yes, it is ketone. Example of ketone, CS3, C double bond O, and there is CS3. But just convenience, I have shown that hydrogen separately. Okay, this is acetone molecule. When that acetone molecule is treated with methyl bromide, CS3Br. Now what happens here? Just that hydrogen atom from the methyl group is replaced by, that hydrogen atom is replaced by another methyl group, this methyl group, and there is the formation of another ketone. That hydrogen is replaced by methyl group. Hence, that acetone is converted into butanone. That acetone is converted into butanone, and that reaction is carried out in presence of base, in presence of KOH or NaOH. Okay, I will repeat again. I will revise again same reaction. Acetone, when treated with the methyl bromide in presence of KOH, aqueous KOH, hydrogen atom from the acetone is replaced by methyl group and we get the butanone. Now let us see mechanism of the reaction, means how actually that process occurs, how that process takes place in number of steps, what are the intermediates formed during the reaction, and how the bonds undergo breaking and how the new bonds are formed. Let us see mechanism of the reaction. Okay, now in first step what happens? In first step, acetone react with the base. We are using KOH or NaOH. Means there is a OH minus, there is a nucleophile OH minus. Now what happens here? In first step, that OH minus takes one hydrogen atom, takes one alpha hydrogen atom, and thus that OH minus takes that hydrogen atom, that OH and that hydrogen, there is a formation of water molecule. Then the bond between that carbon and hydrogen, this bond undergo breaking. This bond undergo breaking, and that bonded electron, this bonded electron pair goes towards, this bonded electron pair goes towards carbon. Thus, that hydrogen and OH form H2O. This electron pair goes towards carbon. It acquires negative charge. There is a formation of negatively charged carbon species, and that intermediate having negative charge on the carbon. Therefore, it is called carbanion. Okay, this is the first step, formation of carbanion. Now, what is the second step? In second step, methyl bromide react with the carbanion, and then there is the formation of bond between that carbon and methyl group. Here, this bond undergo breaking. या ठिकाणचा बॉन्डचं ब्रेकिंग होतं and electron pair जातं bromine कडे. It acquires negative charge. There is a Br minus, and this is the new bond. This is the new bond between carbon and this new methyl group. This is the new bond between carbon and methyl group, and this is example of chemical reaction. I have explained a very simple reaction of organic reaction in which there is a formation of carbanion as an intermediate. Okay, now let us see. I will repeat again. I will revise again. Acetone react in first step with the nucleophile with the OH minus. That OH minus takes that one hydrogen atom. It takes that hydrogen atom. That OH minus and hydrogen form H2O. This bond breaks heterolytically and electron pair goes towards carbon. It acquires negative charge. There is a formation of carbanion. Now this carbanion further react with the methyl bromide. मग हा मिथिल ग्रुप आणि इथला कार्बन there is a formation of bond between that methyl group and carbon. This is the new bond. Ha navin bond आहे actually. This is the new bond actually. Okay. Now that bond breaks heterolytically. कारण मिथिल ग्रुप आणि कार्बन मध्ये नवीन बॉन्ड तयार होतो. मीन्स द प्रिव्हियस बॉन्ड बिटवीन कार्बन, मिथिल ग्रुप अँड ब्रोमीन undergo breaking. That electron pair goes towards bromine. It acquires negative charge. There is a loss of Br minus, and we get the main product, and that main product is nothing but the butanone. And thus, this is about just simple conversion of acetone into butanone, and that conversion, that process, that chemical reaction involves formation of carbanion as an intermediate, and therefore we have studied that reaction, how there is a formation of carbanion during the chemical reaction. Now let us see one more very interesting reaction. I think all of you are very well known about this reaction. I will explain. Yes, this is aldol condensation. Okay, you are studied that reaction at 12th level, but I am going to discuss in again detail about that aldol condensation. Okay, very important organic reaction. Here, this is example of aldehyde. Name of the compound is CH3CHO. Name of the compound is the acetaldehyde. CH3CHO acetaldehyde. When that acetaldehyde is heated, when that acetaldehyde is warm with dilute NaOH, it is warm with dilute KOH or NaOH. What happens here? That acetaldehyde undergo condensation. Means two molecules of acetaldehyde participate in the reaction. Okay, this is the previous first molecule, and this one is the second molecule of the same compound, acetaldehyde. Now that two molecules undergo condensation. Actually, what happens here? Here, that second molecule of acetaldehyde, this is the second molecule of acetaldehyde, it adds to that carbonyl group. It adds to that carbonyl group hydrogen atom from the methyl group. Here, that hydrogen atom from the methyl group, it adds to this oxygen, while remaining part adds to carbon. Remaining part adds to carbon, and we get the addition product. Okay, this is the addition product. This hydrogen, I have shown that hydrogen here. This is the hydrogen. Okay, then that hydrogen from the methyl group adds to oxygen, and it becomes OH. It becomes hydroxy group. While remaining part CH2, हा remaining part जो आहे, that remaining part adds to directly this carbon. It adds to this carbon, and there is a formation of condensed product. Actually, this is that reaction. That product, the final product is called aldol, simply aldol, and name of the compound is beta hydroxybutyraldehyde. And that aldol, that particular compound, is very well-known compound, and that reaction is called aldol condensation. Acetaldehyde, when warm with dilute NaOH, undergo condensation, there is a formation of beta hydroxybutyraldehyde. Why it is called beta hydroxybutyraldehyde? Actually, this compound having 4 carbon, 1, 2, 3, and 4. Therefore, aldehyde is called butyraldehyde. This is the nomenclature system, butyraldehyde, common name. Okay, now beta carbon having hydroxy group. Actually, first carbon from the aldehyde is alpha. Okay, this is the alpha carbon. Then second carbon is the beta carbon. It having hydroxy group. Therefore, it is called beta hydroxybutyraldehyde, or simply they are called aldol. Why they are called aldol? Because that compound having both the functional group. One is a aldehyde, and second is the OL. OL means alcohol. Okay, there is OH group, means there is alcohol, and hence that compound is called aldol. Okay, and thus aldehyde, when heated with the dilute NaOH, actually in this reaction, those aldehyde or ketone which having alpha hydrogen atom. Alpha hydrogen means that carbon is called alpha carbon, and if it having hydrogen, they are called alpha hydrogen. And those aldehyde or ketone which having alpha hydrogen atom, when warm with alkali, undergo self-condensation, and there is a formation of aldol, and that reaction is called aldol condensation. Actually, we have to study how the formation of intermediate, or we are going to discuss mechanism of the reaction. Let us see mechanism of the reaction. Here, this is our acetaldehyde, CH3CHO, but here also for convenience, I have shown that hydrogen separately. This is the aldehyde molecule, acetaldehyde molecule. Now, in first step, base, that is OH minus, takes that hydrogen atom. तो एक hydrogen, alpha hydrogen घेतो. Therefore, bond between that carbon and hydrogen undergo breaking. Electron pair goes towards carbon, and now there is a formation of negatively charged carbon species, carbon having negative charge now. Okay, while that OH minus and hydrogen, it form H2O as a byproduct, water molecule as a byproduct, and carbon having negative charge, and that species is called carbanion. Thus, in this reaction, in the mechanism of aldol condensation, there is a formation of carbanion in the first step. OH minus nucleophile takes hydrogen atom, and there is formation of carbanion. Now, in second step, what happens here? That carbanion further attack on the second molecule of acetaldehyde. This is our carbanion, which is formed in the first step, while this is the second molecule of acetaldehyde, CS3CHO. Now what happens here? This carbanion attack on the second molecule of acetaldehyde. This negative charge means electron pair. This electron pair form a bond between that two carbon. It form bond between that two carbon. Now to maintain the valency of this carbon, म्हणजे या कार्बनची व्हॅलन्सी मेंटेन करण्याकरिता काय होतं, वन ऑफ द पायबॉन्ड, इथं असणारा पायबॉन्ड ब्रेक होतो, अँड दिस इलेक्ट्रॉन पेअर गोज ऑन द ऑक्सिजन. म्हणजे या दोन्हीच्या मध्ये नवीन बॉन्डचं फॉर्मेशन होतं, while one of the pi bond undergo breaking and this electron pair goes towards oxygen, it acquires negative charge. Now this is the negative charge on the oxygen, while there is a bond between that two carbon. या दोन कार्बनच्या मध्ये या नवीन बॉन्डचं फॉर्मेशन होतं. This is the new bond actually between that two carbon, and we get the intermediate. That intermediate is called alkoxide intermediate. Okay, now what happens in the next step? That alkoxide intermediate first take one proton from the water molecule. It takes one hydrogen from the water molecule. Actually, there is a negative charge on the oxygen. There is OH minus, O minus. Now that O minus and that hydrogen atom, या water मधला एक hydrogen घेतो, and it becomes OH group. It becomes beta hydroxybutyraldehyde, and byproduct is the OH minus. म्हणजे इथला H2O मधला एक हायड्रोजन घेतो, म्हणजे इथून OH minus बाहेर पडेल, and there is the formation of main compound, and this is nothing but our beta hydroxybutyraldehyde, that is aldol. Means here what I have explained, yes, I have explained the mechanism of aldol condensation. You are already studied that reaction, but I have just revised the mechanism of aldol condensation. First step is the formation of carbanion. Okay, nucleophile takes one hydrogen atom, one proton from the acetaldehyde. There is a formation of carbanion. Second step, attack of carbanion on the second molecule of aldehyde to form alkoxide ion, and that alkoxide ion first take proton, again take proton from the water molecule, from the solvent, and there is a formation of expected product, that is beta hydroxybutyraldehyde. Okay, this is just about the mechanism of this reaction, and also about the second reactive intermediate. Yes, carbanion. We have studied that reaction intermediate in 5 steps. First is the introduction, second is the formation or generation, then third is the structure, fourth step is the stability, and last step is the reactivity of carbanion.